talking about the renal system. What is the renal system? It's a filtration system. Here it comes from the aorta, filters the blood, and then puts it back through the vein or the vena cava. What happens right here is the main key ingredient in the glomerulus region. This is Bowman's capsule. This is where the artery comes in and it filters the blood into a collection tube that will eventually turn into urine. The main issue right here is, see, we have the RBCs that are carrying water, electrolyte, glucose, amino acids, fatty acids, vitamins, urea, and creatinine, and they go through what is called a basement membrane right here in this filtration system of the Bowman's capsule. And they fit right through here, and all this is taken out right from here. The bottom, remember, the blood comes in, it is filtered out, all these nutrients are filtered out, and the blood goes out. Then what happens is the body says, the kidney says, do we reabsorb this or not? Right here in this part of the tube, we reabsorb glucose, amino acids, bicarbonate, sodium, water, chloride. Then as we come down the tube further, we absorb more water. Where do we absorb this? Back into the arterial system, this arteries that run around here. Then we take out more sodium, potassium, chloride, sodium, potassium, calcium, magnesium. We take all this back out so we're not what? Dumping it to the urine. So right here, we actually put potassium and hydrogen back in. So there's a reason here. What are we really looking at? The blood needs to be filtered. So it's an actual refilter process. First we take all of these out of the blood. Then we reabsorb them through this tube and put it back into the blood system. If we don't reabsorb it, it becomes waste. Mainly what is waste going to be? Water, urea, nitrogen. These are our main waste products. But here, this is where a lot of diuretics work. The osmotic diuretics, the loop diuretics, the potassium-sparing diuretics. They help change how much we give back or how much we give to this system. Mainly, it is fluid, water, that we're taking out of the system and not reabsorbing. So diuretics are not really just a water pill. They stop us from reabsorbing the water out of the collecting tube back into the blood system. So what you must know about a kidney is that an artery comes in, small arteries, all over. There's tons of these arteries all over up here, and we filter the blood and we collect urea down here in the giant collecting area, and then it goes down to the bladder. Right through here in this smaller area in the Bowman's capsule, there's tons of nephrons that we filter blood. We take all the stuff out of the blood and then we reabsorb it through the collecting tube. That is what? Creating what we don't reabsorb is all waste and urine. And mainly that is going to end up right here to then go to the bladder, and then we can discharge it. So is there much that we need to know about that? That is the main way that we need to know. The filtering process of the kidney is to create what? Waste. We have a reabsorption process that can be a problem if we have too much glucose in our system. We'll start what? Discharging waste because we can't absorb all there. There's a maximum threshold that we can reabsorb glucose, and then we'll discharge. So anytime you see excess protein or excess glucose in a urinalysis, you know that the collecting tube is not able to reabsorb that material any longer, and so the body determines it as waste. It's really important to understand this process of the kidney. That is all that it really does, but it's very, very important. This simple thing here that you see, the blood pressure coming in is 60 millimeters per hemoglobin, and when it comes out it's 50. It's constantly readjusting to keep this pressure in check. It cannot function other than 60 and 50. So if we suffer from chronic hypertension, we're doing what? We're taking pressure and having to constantly readjust it so this will function correctly. Another thing you need to remember is how many liters per day of blood do we filter? Right here, 150 to 180. That's a lot. And we're constantly taking out what? All these nutrients and then reabsorbing them as we do checks and balances with our blood system to say, do we need calcium? Yes, we do, so we'll reabsorb it. Do we need magnesium? Yes, we'll reabsorb it. If we don't, we'll leave it in the collecting tube and it'll eventually end up as waste. As far as the general adjustment for blood pressure, if the blood pressure is low, the kidney recognizes it, it creates renin, and it combines with angiotensinogen to be angiotensin 1, which then is converted to angiotensin, it's converted to angiotensin 2 by the angiotensin converting enzyme. This is where your ACE inhibitors stop this process. So what will happen is we'll get vasoconstriction and increase of blood pressure. Also, the hypothalamus will create or secrete more antidiuretic hormone, meaning that we'll what? This will happen when we have thirst and we're lacking water. So we'll do what? We'll reabsorb more water through the collecting tubes in the kidney. Same thing right here. When there's more aldosterone, we pay attention to what? Sodium and water. And we what? We reabsorb more sodium and water out of this collecting tube instead of letting it go as waste. So the one thing that you must understand is that there's an artery coming in to the main kidney. It gets into a smaller artery, into a little nephron where there's a Bowman's capsule. We filter that. We take out all the nutrients. We pass it through these what we call collecting tubes that where we're going to form waste or urine. And as we're forming this, we're taking out, reabsorbing into our blood system what we need. So it's a checks and balances, double down system. We know exactly what we need based upon what? Our 150 liters a day that we keep readjusting to. And so if we don't do a lot of exercise in the morning, but we do a lot in the evening, we'll reabsorb more water in the evening time based upon how this system down here is monitoring the blood system. Thank you.